All right, greetings YouTube. This is Beautiful Mind. This question comes in from one of my students on. This comes out of the subject of finite math on counting using Venn diagrams to count. Let's see. So this is finite math. This comes from our book, section 5.3, question 21 out of the back of that section. So it says, let R, S, and T be subsets of the universal set U. Okay. It says, draw an appropriate Venn diagram and use the given data to determine the number of elements in each basic region. Okay. Then choose the correct answer on the right. Okay. So with something like this, you want to start with the Venn diagram, and then usually when I'm filling in Venn diagrams, I work my way from the center to the outside. Okay. So typically, when I'm filling in Venn diagrams and I'm assessing the information, again, typically I start from the very center. So in this case, I'm going to start from region 5. Okay, so let's see if we can find that piece of information. So region 5 is the region that's not only is it inside of R. So okay. So region 5 is that region in the center where you see it's not only inside the set R, it's also inside the set T, it's inside the set S, it's inside all the sets. So that's a region that's the intersection of all three. Remember, intersection is what's inside of the first set and the second set and any other set that is intersected with. So in this case, okay, let's do it like this. So we have that, but I'm gonna kind of draw my own circles real quick. Okay. So like this is my R. All right, here's R. Here's T. Here's S. Okay. And then I have my universal set. Now I know I have it to the left, but I'd just rather use my drawing. Okay. So now, again, when you're filling these in, you don't just plug the numbers. You have to kind of work, but you have to work your way from the center to the out, and we'll break it down. So now the center is R and S and T, so it says that that's 2. So this region is 2. It almost looks like a shield, that shielded region. It looks like it's a 2 to me, okay? So now if we kind of work backwards, it says that the number of elements in R and T, so this part here, is 4. So R and T, so we have that either vesica Pisces or football-shaped region has to add up to 4. We've used 2, so that means this should be 2. Okay, because it says R and T, so the R and T is this with that, but we've already used 2, so there's only 2 left over there. Okay, so if we keep going, it says S and T is 4, so S and T, so we're talking about this region. Now that has to add up to 4, but we've already used 2, so that means the remaining is 2. It says the number of elements in R and S is 3. So R and S is this region. That has to add up to 3. We've used 2, so there's only 1 left over. So that should be a 1 there. Okay? So that's that. Now, keep going. We're still working backwards. It says the number of elements in T. So T, everything inside of T has to add up to 10. We've used 6 so far, so there's only 4 left over. Everything inside the circle T has to add up to 10. Everything inside set S has to add up to 14. We've used 5. So what is that, 9 is left over for S? They didn't tell us R? That's okay, they didn't tell us R exclusively, so, but they give us enough information to fill it in properly. Let's see what else. So then it says the number of elements in R union S is 19. So if you combine all the elements with R with S, it should add up to 19. So thus far, if we look inside of R and S, so basically we're talking about everything inside of this part, this like figure 8 area, it has to add up to 19. Now, so far we used 5, 7, 16. So it sounds like there's only 3 left over. So that 3 goes here, because that's the only region that we didn't know for that part. Then it says the number of elements in R complement is 19. So everything outside of R has to add up to 19. There's only one region we don't know right now. Everything outside of R has to add up to 19. So far, we've used 15. So the only thing that's left is 4. So this outside region is 4. So that's how I would fill in the Venn diagram. So I'm going to check this in my Pearson. I got this from Pearson. Okay, so I am filling this in. So region 1 from our drawing says that there are 4 elements there. Hopefully, oh shoot. Let's see if I can get this to work properly. Oh, come on. Because if I, oh shoot. I think I just lost it. Daggone it. Maybe it's still the same. Hopefully the numbers didn't change. I've got to pull ours back up. Now let's see. We have 19, 19, 14, 10. Okay, it looks like this is okay. So now region 1 should be 4. There we go. Yes, 4. Okay. Then region 2 is there, so ours is, that's where our 3 is, so it should be 3. Okay, and then region 3 is 4 for us. Then region 4 is that bottom part, which is 9 on ours, so that's 9. And then region 5 is the center on our drawing. And our center is 2. 2. 6 is that bottom left, which is 1 on ours. 7 is that top center, which is 2 on ours. 8 is 2 on ours. And that's it. That's it. Yeah. Okay, so we got it correct. So that was an example on how we would answer a question of this type. Okay. So now, again, typically, the way students get this one wrong is that they just don't really think about it. They just kind of match up the numbers, but you have to start your way from the center and work your way out, and you have to kind of go step by step and ask yourself, does this make sense? The number in all 3 is the 2, and then it says in R and T has to add up to 4. R, T, so we had already used 2, so that center football region, so basically regions 5 and 7 has to be add up to 4, but we've already used 2, so on and so on. So you've seen the logic, okay? So with that, we will end the session here, and for one beautiful mind to another, enjoy the rest of your day.